What is the meaning of emission and absorption spectra? So by definition it goes as such that the spectrum of radiation emitted by a substance that has absorbed energy is called an emission spectrum. It means what? A substance or you can say an atom, a molecule that has absorbed some energy, and when this energy is released you can observe the spectrum of radiation, and that spectrum is called the emission spectrum. So when an atom or when a substance absorbs energy, we term it as excited atom. Okay, excited word is used, and when that energy is released, then we use the term ground state, excited state and ground state. When an atom is absorbing energy or it has gained some energy, it is said to be in the excited state, and when that energy is released it will come back to the original state, which is known as the ground state. So these two things you have to remember here. Now when we say absorption spectrum, it is just the opposite of emission spectrum, and absorption spectrum is like the photographic negative of an emission spectrum. The branch of chemistry that deals with the study of emission or absorption of spectra is referred to as the spectroscopy. So this is a whole branch of chemistry or a subject of chemistry. Line spectra is a type of emission spectra of atoms in the gas phase. So in the any substance that is there in the gas phase will tend to give the line spectra. Line spectrum of hydrogen. So there are a series of spectrum known as the Lyman, Balmer, Paschen, then Brackett, then Pfund. So these are the series that is observed in hydrogen spectrum. So when do we observe the Lyman series? When the electron jumps from the first state, that is your number 1 quantum number n1 to higher than 1, that is 2, 3, 4, 5. When Balmer is observed when the electron jumps from the second state to the third, fourth and fifth. So 1, 2, 3, 4 it goes on, and the name is respectively Paschen, Brackett and Pfund, but it will jump to a level higher than it. That is, if it is 3 it will start from 4, 5, 6, 7. Okay, if it is 4 it will start from 5, and if it is 5 it will start from 6. And this Lyman series falls in the ultraviolet region, Balmer falls in the visible region, and Pascal in the infrared region. So this one you have to memorize. So if we see in the diagram here, you can see this is the energy level. Okay, the energy level is increasing from 1 to 10. When we talk about Lyman, we know that the electron will jump from level number 1 or state 1. So the electron will jump from 1 to 2, or it will jump from 1 to 3, or from 1 to 4 up to 1 to 10. It is possible, since we have said that the starting will be 1 and we don't know where the electron will stop. It can jump up to 2, it can jump up to 3, a level up than 1. Similarly, when we talk about the Balmer series, the starting is 2. The electron will start at 2 position. So from 2 to 3, from 3 to 4, 3 to 5, like that it goes on. And this is how you can draw the series. Now the spectral line of hydrogen obeys the formula, that is their wave number nu equal to wave number, this is mu bar, equal to 109677 within bracket 1 by n1 square minus 1 by n2 square. So what are these n1 and n2? Suppose we say that the electron has jumped from 1 to 5, then it will be here n1 will be 1 and n2 will be 5. So 1 by 1 square minus 1 by 5 square, where 109677 is the Rydberg's constant. So this constant also you have to remember, it is 109677, and this is a formula by which you can calculate the wave number. Bohr's model for hydrogen atom, it is an important concept. So let us see what are the postulates, what are the conclusions that was drawn from the Bohr's model, what were the things proposed by it. So it is said that the electron revolve around the nucleus in certain circular stationary path called orbit. So the electrons is moving around the nucleus, but the path is very definite, and those paths are known as the orbits. Okay, so electron revolve around the nucleus in certain circular stationary paths. So stationary path, those paths are fixed, they cannot move out of that path, is called the orbit. When electron absorbs energy, it goes from low level to high level, and when it releases energy, it moves from the high level to the low level. I have already talked about it, about the ground state, excited state. So when an electron absorbs energy, it will move from low energy level to high energy level, obviously. Okay, and when it releases energy, it will come back to the original state, that is your ground state. It means it has moved from the high level energy to the low level energy. The third one is a formula where energy transaction revolves frequency, which can be given as E equal to h nu. Nu is equal to delta E by h. Delta means difference of energies. Okay, so if we talk about here difference of energies, it will become E2 minus E1. Here also one delta should be there. Okay, delta E equal to h nu. So difference of energy means what? Initial energy minus final energy minus initial energy. So it will be E2 minus E1. Angular momentum. The term means that when a body is rotating, it will have some amount of kinetic energy, right? And that energy is related to the angular momentum. So the momentum that is related that of a rotating body around an axis is termed as the angular momentum. In physics, it is well defined. You have already studied about it. So angular momentum is associated with energy of the electron, which can be given as mvr equal to nh by twice pi. So n is the number of the state. We can also calculate the energy of that state by the formula E, and N is, you know already, 1 2 3 4, that state name. So energy of a state is given by minus RH, that is the Rydberg's constant, into 1 by n square. Whatever, if we want to calculate the energy of like a second state, so it will be E2 equal to minus RH 1 by 2 square. RH is the Rydberg constant, and what is the value? 2.18 into 10 to the power minus 18 joule. The next one is de Broglie's hypothesis or de Broglie's equation, which is lambda equal to h by p. It gives the relationship between wavelength, that is your lambda, and momentum means p. Okay, h is a constant. Now you know that P is equal to mv, so lambda equal to h by mv. So this is the de Broglie's equation you have to remember. The next one is the Heisenberg's uncertainty principle. So suppose you consider a small body, that is a microscopic body like the electrons. So what happens when that electron is moving around the nucleus? It is not possible for us to detect the position because it is constantly moving. At that time we can detect the velocity of the electron, right? But again, if you want to detect the position, what happened? You have to stop that electron, which is not possible, right? So if you stop that electron, you can detect the position, but it is not possible for us to calculate the speed of the electron, the velocity of the electron, because now it is not moving. So what did Heisenberg say? That it is impossible to determine simultaneously, means together, the exact position or exact momentum of an electron. If you can calculate the position, you won't be able to calculate the speed. If you able to calculate the speed, you won't be able to calculate the position, because both differs. Now this uncertainty equation is given as delta x. Okay, so this is the position into delta p, momentum, is greater than equal to h by 4 pi. So delta x is position of the electron, delta p is momentum of the electron, m is the mass of the electron, v is the velocity. So in place of p you can also write mv, right? Mass into velocity. So mass is constant, so you cannot put the delta in front of it, because there is no difference in the mass. Initial mass and final mass will be same, so constant, so m. Then delta v can be changed. So change in position or change in momentum is greater than equal to h by 4 pi.